In the previous episode, I created the outer shell for the Mini Commodore 64 and did a quick test print of the case. In this video, I will start working on modeling the internal structures, and we need to find a good placement for the Raspberry Pi and all the connectors. Let's look at the different options for where we can place the Raspberry Pi. One option is in the upper left corner that would make it easy to access the microSD card. Another option is to put it right in the middle of the case, which would give us more flexibility for placing all the connectors. We can use extension cables to route them where we want. But to keep it simple, I think I will place it in the upper right corner. That way we will have easy access to all the USB ports and the LAN port. Let's open up Fusion and start modeling. I started by creating a simplified model of the Raspberry Pi. This makes it easier to design the case around it and to get accurate cutouts for the ports. After adding the 40-pin connector, I modeled the USB and LAN connectors. Then I added the HDMI, audio and power plugs. With that done, I placed the Pi inside the case. I positioned it in the upper right corner and added some mounting pillars to lift it up a bit. I created a cutout for where the external ports will go. I also thickened the wall so the top half would sit firmly on the lower part. I added mounting pillars to attach the top and bottom halves. I also created a side panel with openings for the ports. The pillars were extended to make it easier to align the top and bottom halves later. I added some 45-degree chamfers to reduce the need for supports when printing. I made the pillars stronger by adjusting their shape. Finally, I finished the cutouts for the upper part of the case. At this point, I realized that if I'm going to build a USB keyboard, I won't be able to plug it in because all the USB ports are now on the outside of the case. I decided to move the Raspberry Pi to the center of the case and use extension cables. I started modeling the plug of the USB extension cable. And then I did the USB power connector. After that, I modeled the HDMI connector. Next was the plug for the microSD extension cable. I created a mount for it. And then I did the same for the HDMI connector. And finally for the USB and power plug as well. Once all the mounts were modeled, I printed a few test pieces to check if the cables would fit. The microSD reader was a bit too loose. The HDMI connector was angled a bit downwards, so it needed some adjustment. The power connector did not fit at all, so I must have messed up the measurements for that. The USB connector was pretty good and just needed a small adjustment. I fixed the angle of the HDMI mount so the plug would sit flat. I made the mount for the microSD reader a little bit tighter. I resized the cutout for the power plug so it would fit properly. Then I added some screw holes to secure the connectors. I designed some small clamps to hold the connectors in place. And with those changes done, I printed another test batch. The microSD reader now fit perfectly. The angle of the HDMI connector was now okay. The USB plug and power connector also fit nicely. The clamps could be a bit tighter. After making a mountain of test prints, it was time to print the entire case. I imported both the top and bottom halves into Bamboo Studio. In the previous video the layer lines was quite visible, so this time I used variable layer heights in an attempt to improve the surface finish. I set the quality to max to enable smooth transitions. This did, however, increase the print time from 4.5 to 6 hours. I started with printing the upper half. The layer lines was less visible this time. But now I had a new problem with blisters in the surface. And it was especially bad on the back of the case. I think this is caused by the frequent changes of layer heights and different extrusion rates. On the inside, the bottom layer came off when I removed the supports. Looking at the infill, I was not surprised that the surface looked bad as well. I tried again, but this time I used the default settings for variable layer heights. I also added a few more top and bottom layers. This improved the surface quality a lot. But the front of the case was still not perfect. The inside looked better, but I had a hard time to remove the supports. To fix this, I added more 45-degree chamfers to reduce the need for supports. I turned off supports for bridges, which reduced the support area to just a small section in the middle. It was time to start another test print. As you can probably see, this print was a complete failure. I assumed the slicer would bridge in the shorter direction, but that was not the case. By looking through the layers in the slicer, we can see the problem clearly. The bridge lines went across the entire length of the case. To fix it, I manually set the bridge direction to 90 degrees. And now we can see the bridging is in the shorter direction. I started one more test print. This time the result was exactly what I hoped for, with a smooth, clean surface all around. To make it look even nicer, I printed out a picture of the Commodore logo and the power light on paper. Then I cut it out with some scissors. I used a little bit of glue to attach it to the case. Eventually I will try to 3D print the logo as well and use an actual LED light for the power indicator. Then I printed the bottom half of the case. Before test fitting, I had to modify the USB cable by removing the mounting ears so that it would fit properly inside the case. I did that quickly with the rotary tool and the edges came out a bit rough, but that won't be visible anyways once the case is assembled. Now let's have a look at the bottom half. I started to add the heat insets. I tried my best to make them go down in a straight angle. After that I started to assemble all the components. I added the MicroSD extension cable first and then the Raspberry Pi. It would probably have been easier to plug in the microSD extension cable before mounting the Raspberry Pi. I put the flat cable under the HDMI cable to hold it in place. Finding somewhere to put the excess cable for the USB extension was a bit more difficult than expected. But after fiddling around for a bit, I found a solution that works. Then I mounted the bracket for the USB and power plug. And finally the bracket for the microSD plug. I'll start working on the keyboard in the next episode, but it's already starting to feel like a real mini Commodore 64. If you enjoyed the video, consider subscribing and hit the notification bell so you don't miss any future updates. Feel free to leave a comment if you have any suggestions on things I could improve. The next episode will be a bit of a challenge because I need to model all the keys, which not only have text on top, but also symbols on the front. To be able to print the finer details of the small keys, I will also have to change to a 0.2mm nozzle. And that's all for today. See you in the next one.